Welcome to MS 100 lessons, and in this lesson I will be focusing on an inclined plane angle theta analysis. So looking at the outcomes for this lesson, I will be talking about how the angle theta of inclination of a surface affects the forces that are acting on an object. Okay, so I will explain this concept using two examples whereby we are changing the variable theta. So for the first example, I'll be using theta as 20 degrees. And for the second example, I'll be using theta as 40 degrees. And we will be checking the effect of this angle theta on the forces that are acting on that object. Okay, so let us go to example number one, which is angle theta of 20 degrees. So for these examples, we will be doing our analysis for Newton's second law, whereby we follow the steps of analyzing Newton's second law, right? So we have an angle theta on the surface. The angle of inclination is 20 degrees, okay? So now let us read the instruction. The instruction says an object of mass 5 kg, right, is sliding down a rough inclined plane. So if it is a rough inclined plane, then it means we have friction, right? We have kinetic friction since the object is sliding down, it is moving. So, and the surface has a coefficient of kinetic friction of 0.2, right? So it means the coefficient of kinetic friction is equal to 0.2. All right, so we just want to analyze this question in terms of the steps that we follow for Newton's second law, whereby we say step number one, you separate the objects if there is a connection of if there is a connection of particles by a rope. But in this case, there's only one object, okay? So there is no need to separate objects. Then now step number two, you draw a free body diagram for that object, okay? And then it means we'll be showing all the forces acting on that object in our free body diagram. And then step number three, we resolve any forces that needs to be resolved, okay? So in this case, we will be using our axis or our system of axis as x and y, right? So anything which is not in the x direction and that y direction will be resolved, okay? So that is step number three. And then step number four, we obtain our F net in the y-axis, right? And the main reason to obtain the F net in the y-axis is to obtain the net force so that we can calculate our frictional force. And then the next step, which is step number five, we obtain our F net in the x-axis. And then the last step, we solve any variables which are unknown. All right, so let us follow these steps to analyze this question, right? So step number one, we separate. There's no need to separate objects because there's only one object in this case. And then step number two, we draw a free body diagram for this object. So let us draw a free body diagram for this object. And that is step number two, okay? So the free body diagram of this object, we represent it with a dot showing the center of mass, okay? So since we have mass, we have gravitational force acting downwards, right? And remember, the object is moving downwards, down the incline, so it is sliding down the incline. So the forces that we have Fg, which is going downwards, and we have normal force which acts perpendicular to that surface, right? So we have normal force acting perpendicular to the surface. Okay, and now since the object is sliding downwards, it is sliding down the incline, so it means the friction will be acting up the incline. It opposes the direction of motion. Okay, so these are the forces that are acting on that object as the object slides downwards. Okay, so now we go to step number 3. Is there a need to resolve? So if we check our system of axes, we have that y-axis and the x-axis, right? So looking at the y-axis, we have normal force acting on that y-axis. Okay, so the normal force, there is no need to resolve the normal force. And we also have Fk acting in the x-axis or in the x direction. Okay, so there is no need to resolve that Fk. But looking at Fg, Fg is not in the y direction, okay, and it is not in the x direction. So we have to resolve this Fg. So when we resolve Fg, we will have two components of weight, right? The first component is the Fg perpendicular, which is Fg perpendicular to the surface, right? And the second component would have Fg parallel, which is parallel to the surface. The other one is perpendicular to the surface, okay? So the fact that we have represented Fg with the components, we can now remove it from the free body diagram. So that is step number 3. We have resolved weight into two components. But remember, Fg perpendicular is mg cos theta, and Fg parallel is mg sin theta. Okay, so now let us go to step number 4. Step number 4, we find our net force in the y direction in order for us to calculate the normal force and the friction. Okay, so step 4, F net is equal to ma in the y direction, right? So how many forces do we have in the y direction? We have the normal force, which is positive, and we have Fg perpendicular, which is negative, right? Provided that we are choosing that direction as positive and that direction as negative. So we have normal force, which is positive, minus Fg perpendicular, okay, which is negative, and that is equal to the mass of the object multiplied by the acceleration, but the object is not accelerating in the y direction, so the acceleration in the y direction is equal to 0. Okay, so we now have normal force minus Fg perpendicular is equal to 0, and our normal force is equal to Fg perpendicular, right? But we do know that Fg perpendicular is equal to mg cos theta. So in this case, the mass was given as 5 kg, and g is 9.8, and cos, the angle of inclination in this case is 20 degrees. Okay, so it means the normal force will be 5 times 9.8 times cos of 20 degrees, and that will give us 46.05 newtons. So now we have obtained our normal force, right? So we can now calculate the friction. So after obtaining the normal force, we can calculate the friction. The friction will be Fk equals to the coefficient of kinetic friction multiplied by the normal force. So Fk is equal to the coefficient of kinetic friction we are given as 0.2 from the statement. So that is 0.2, and the normal force we obtained 46.05. Okay, so Fk is equal to 0.2 multiplied by 46.05. So that is our frictional force, which is 9.21 newtons. Okay, so that is the magnitude of the frictional force, and the direction of the frictional force is up the incline, right, as you can see from the free body diagram. All right, so the next step is to find the net force in the x-axis, right? So how many forces do we have in the x-axis? We have two forces, right? So if we were to conduct the F net in the x-axis, let me just erase this so that we have more space. So that was F net in the y-axis. So now we want to find F net in the x-axis. So F net is equal to MA, the x-axis. How many forces do we have in the x? We have two forces in the x direction. We have friction, which is positive, provided that we are choosing that direction as positive and that direction as negative, right? So that would be equal to friction, which is positive, right? Because up the incline, we're saying it's positive, minus Fg parallel, which is negative since it's down the incline, right? And that would be equal to the mass of the object. And what about the acceleration? The acceleration, this object is accelerating in which direction? It is moving down the incline, right? So if it is moving down the incline, then it means the acceleration would be negative. Then that would be negative a, okay? If we look at Fk we have already calculated, which is 9.21. And then what about Fg parallel, right? Fg parallel is equals to mg sine theta, okay? So let us calculate Fg parallel up there. Then there would be m, which is 5, g, which is 9.8, and then sine 20, okay? So that would be 5 multiplied by 9.8 multiplied by sine 20. Then it means Fg parallel is equal to 16.76 newtons, right? 16.76 newtons, and the mass of the object is 5 kg, and that is the acceleration, right? So it means on the left hand side we'd get 9.21 minus 16.76, and we obtain negative 7.55. So we get negative 7.55, which is equals to minus 5a. We divide both sides by negative 5, okay? Then the acceleration now becomes 1.51 meters per second squared, right? Which is down the incline. Okay, so looking at this analysis, we can see that if the angle of inclination is 20 degrees, right? From our steps, the normal force that we get, we are getting a normal force of 46.05, right? So let me write the conclusions here. We obtain the normal force as 46.05 newtons, right? Because the normal force is equal to Fg perpendicular, right? And then the friction that we have obtained friction of 9.21 newtons, right? And we have obtained an acceleration of 1.51 meters per second squared. So this is what we have calculated from our analysis when theta is equal to 20, right? So now let us increase the value of the angle theta to 40 degrees, right? So we want to see the value of the normal force that we will obtain, the value of the frictional force that we'll obtain, and the acceleration that we will obtain now that angle theta has been increased to 40 degrees, right? Then now we can come with a conclusion on the effect of the angle theta on the forces acting on an object. So let us follow this very same steps that we followed up here. We said step number 1, you separate, right? But looking at this, there's no need to separate, okay? And then step number 2, you draw a free body diagram. So let us draw a free body diagram on this object. So for step number 2, the free body diagram, we have FG, which is acting downwards, right? And since we have a surface on an incline, we have normal force in that direction. And since the object is sliding downward, right, same scenario, we have frictional force acting in that direction, okay? So these are all the forces that are acting on the object, right? So now the system of axes that we are using, it will be the x and the y axis in that form. So we can see that normal force is in the y direction and frictional force is in the x direction. But Fg is not in the y and it is not in the x direction. So if we were to plot Fg on that system of axis, would be in that direction. So now we have to resolve this into two components, right, of Fg. So when we resolve the two components, or when we resolve this Fg into two components, we'll have that component, which is Fg perpendicular, and Fg perpendicular is equal to mg cos theta, right? And then we'll have Fg parallel, right? And Fg parallel is equal to mg sin theta. So now that we have resolved this Fg, we can now remove it from the free body diagram, okay? So now we have Fg perpendicular, which is in the y, and we have Fg parallel, which is in the x, right? So that was step number 3, which was resolving. So now let us continue to step number 4, finding the F net in the y-axis so that we can find the normal force and the frictional force, right? So now if we perform the F net in the y-axis, that would be F net. And remember, this is step number 4, right? So for step 4, F net in the y-axis, F net is equal to ma. And how many forces are in the y direction? We have 2 forces, right? And provided that we are choosing that direction as positive, that direction as negative, that direction is positive, and that direction is negative, we have the normal force, which is acting in the positive y, and we have Fg perpendicular, right, which is equal to the mass multiplied by the acceleration. But the acceleration is equal to 0 in the y direction since the object is not moving in the y direction, okay? So we have normal force minus Fg perpendicular equal to 0. So the normal force is equal to Fg perpendicular, right? And Fg perpendicular, from step number 3 where we were resolving, we said it is mg cos theta, right? So that is mg cos theta. So now the mass of the object is 5, g is 9.8, and then cos, the angle now is 40 degrees because we have increased the angle of inclination, right? We want to see the effect now on the normal force. So if the angle theta is now equal to 40, then it means the normal force is equal to 37.54 newtons, okay? Okay, so now let us compare this normal force that is obtained from this angle of inclination of 40 with that which was obtained with the angle of inclination of 20. Okay, so if the angle of inclination was 20, we obtained 46.05. Okay, but now if the angle of inclination is 40, we have obtained 37.54. So it means that if you increase the angle of inclination, your normal force actually decreases. Okay, so let us continue. So we have performed our Fnet in the y-axis to find the net force in the y-axis, and we have obtained the normal force. Now we have to obtain, or we have to calculate the frictional force now. So the frictional force would be Fk equals to the coefficient multiplied by the normal force. So Fk is equals to the coefficient is 0.2 and the normal force now is 37.54, right? So as you can see that frictional force is a function of the normal force. If the normal force changes, the frictional force also changes, right? And in this case, the normal force has decreased to 37.54 if you increase your angle of inclination to 40 degrees, right? So if the normal force decreases, we also expect that the frictional force decreases. So the frictional force now would be 0.2 times 37.54. And the frictional force that we are obtaining is 7.508 newtons. Okay, so let us look at what we have obtained before when the angle of inclination was 20. The angle of inclination is 20, but the frictional force now was 9.21. And the fact that we have increased our angle of inclination to 40, we are obtaining frictional force of 7.508. So when we increase the angle of inclination, we actually decrease the normal force and we also decrease the frictional force acting on that object. All right, so let us continue to perform the Fnet now in the x-axis. Okay, so Fnet in the x-axis, Fnet equals to MA, and remember this is step number 5, Fnet in the x-axis. How many forces do we have acting in the x-axis? We have two forces, right? We have Fk and Fg parallel. And remember, from our system of axis, we are choosing up the incline as positive, down the incline as negative. Okay, so now Fk will be positive, okay, according to our system of axis, and Fg parallel would be negative, and that is equal to the mass, and the object is accelerating down the incline, so that is negative A. Okay, so Fk we have calculated it as to be 7.508 minus Fg perpendicular. We can calculate Fg perpendicular, oh sorry, Fg parallel to be mg sine theta. So that would be 5 multiplied by 9.8 multiplied by sine 40. So Fg parallel would be 5.9.8, 5 times 9.8 multiplied by sine 40. So that would give us 31.50. Okay, so it means Fg parallel is 31.50, 31.50. That would be equals to the mass of the object, which is 5, and multiplied by negative A, right? But what we can also note is that Fg parallel, in the above example whereby we had 20 degrees as our angle of inclination, we obtained Fg parallel to be 16.76, right? But in this case, we obtained Fg parallel to be 31.5. So Fg parallel has increased, okay? And we will see that when we further explain the concept of increasing the angle of inclination. So let us continue with the calculation. So 7.508 minus 31.50, that would give us negative 23.992 equals to negative 5a. We divide by negative 5 both sides, okay? So now the acceleration is equal to 4.8 meters per second squared down the incline, right? So let us have those conclusions now. So if the angle of inclination is 40, right, FG perpendicular, which is the same as the normal force, is equal to 37.54 newtons, right? And our frictional force, we have obtained a frictional force of 7.508 newtons, okay? And the acceleration, we have obtained 4.8 meters per second squared, okay? So let us compare the two. When the angle of inclination was 20 degrees, okay, normal force we got 46.05, but if it was 40, when it was 40 degrees, we have 37.54. So that means increasing the angle of inclination actually decreases the normal force, right? And that applies to the friction also. Friction, we obtained 9.21 when the angle was 20 degrees, but now the angle is 40 degrees and we have obtained 7.5. So when you increase the angle of inclination, okay, so when you increase the angle of inclination, the friction also decreases, right? And now what about the acceleration? When you increase the angle of inclination, you can see that when it was 20, you obtained 1.51, right? But when it was 40, you obtained 4.8. So the acceleration actually increased, okay? So those are the effects of increasing the angle of inclination. And when you decrease the angle of inclination, the opposite would be true, okay?